Hello and welcome to Mr. Pena Has Flipped. This is video lesson number 4, examples for functions and function notation. And the first example we're going to look at says, for the mapping diagram, determine if it is a function. Explain. Here's the mapping diagram. Okay, for the x values, you have -3 and 2. For the y values, you have a book, a happy face, and you have also a clock. Okay, so the -3 goes to the clock, the 2 goes to the book. Ooh, but right there, the the 2 also goes to the clock and the book. It goes to different things at one time. It cannot do that. Okay, it's not a function if it does that. Okay, next example. For the table, determine if it is a function and explain. Well, what I'm going to do is look at the y value after I look at the x value, see which ones repeat. See, I can tell that this repeats and this repeats. Alright, so now I'm going to look at the y values. Do the y values also repeat? I got a 1 here. Here I have a 13. No, it's not a function. In order to be a function, I would have to have -3 and 1, and then the other one would have to be -3 and 1 also. In other words, the y's would have to repeat with the x's also. Not a function. How about this one? A little bit different. Okay, now this one I'm going to look at the x's again. And I notice that the 3 and the 3 repeats over here. Bam, right here, it's got a 1, and this also has a 1. So this is a function because both of the y's repeat in addition to the x's repeating. It's a function. Example number 5. Rewrite y equals 2x squared plus 3x minus 4 using function notation. Then evaluate f of -2, f of 0, and f of 4. First of all, writing it in function notation, all I do is replace the y with f of x. Everything else is exactly the same. Okay. Now for evaluating -2, what I'm doing here is I'm getting the -2 and I'm plugging it in for the y. Whoa, it's supposed to be an arrow there. And I'm plugging it in for the y. Alright, that's cool. So I plug it in for the y everywhere. That includes here and here, not here. And I evaluate it. That means I get a number, an answer. So I get -2. Alright, so f of -2 is -2. Now I'm going to do f of 0. Now I plug in 0 for all the x's, and the answer I get is -4. So f of 0 is -4. Finally, f of 4. F of 4, plug in for all the x's, and I get f of 4 is equal to 40. It's a bigger number there. Okay, now for this one, for the function graph below, evaluate f of -2, f of 0, and f of 3. So I'm going to look at f of -2 first. So what I'm going to do here is I'm going to get f of -2 by going to the -2. Remember, this is x. And I'm going to go down to my graph, and then I'm going to go over on the y. I actually want the y value. So it's going to be -7. f of 2 is -7. Now for f of 0, well, f of 0 means that the x is at 0. Well, this is my 0. And it's going to go up to the graph and go across. So f of 0 is 1. And f of 3 is -2. Meaning that I want to go to, sorry, f of 3 is here. 3 is here. I'm going to go down. And then I'm going to go across. And this is my y value that I want. So y is equal to -2. Excuse me, allergies are bothering me. Example 7. What are the independent and dependent quantities in this scenario? Okay, Daniel's puppy Rusty grew 25 pounds in 4 months. In April, he weighed 15 pounds, and now in August, he weighs 40 pounds. Alright, independent variable. What are the two quantities we're looking at? Well, here we're looking at the two quantities of time in months and then weight in pounds. Those are the two things. Now, does the weight depend on the months or does the months depend on the weight? Well, the weight depends on the months. Okay, so the weight is dependent, the month is independent, the time. Okay, so the independent variable is going to be time in months, and the dependent quantity is going to be the weight in pounds of the puppy. Okay, example number 8. What are the independent and dependent quantities in this scenario? The more it rains in East El Paso, the deeper the lake becomes in Alvin Park. In the summer of 2014, it rained 5.3 inches and the lake is 4.5 feet deep. So in this case, we got the amount of rain and we got the deepness of the lake. So the independent variable is going to be the amount of the rain. Yeah, in inches. Okay, you also have to put the units there. So that means the dependent variable is the depth of the lake. So how much water you have in the lake at Alvin Park depends on how much rain falls. Okay, and you also have to put the units. So don't forget to do that. Okay, this is the units. Now, when you're doing independent and dependent variables, you're not going to use any numbers. Okay, there are no numbers involved. Alright, so never put numbers. You put the amount and the units. Okay, whoa, that means that's the end of the lesson. Okay, so if you need more examples, see me in class. You can look for some on the internet in Google. But otherwise, I'll see you in class. Thank you.